In talking about statistics and how to organize data, it's really important for you to understand how data can be interpreted and presented in a table. So on your screen, you have three different ways that data can be given to you. In the first one, it's called simple discrete data. So for example, the number of pets living with 60 people sampled at random. The number of pets that they have is either 0, 1, 2, 3, or 4. And then you have the frequency for each one. Notice the frequency for 0 is 11. That means that 11 people have no pets. 25 people have 1 pet. 10 people have 2 pets. 9 people have 3 pets. And 5 people have 4 pets. And in total, the amount of people that we have surveyed or sampled here is 60. Okay, so there's a lot of different things that we can do with this data. We can find the mean of the data. So in order for us to find the mean, we're going to use the following formula. The symbol for mean is X bar, and the mean is going to be the sum, that's capital sigma, of each value, X of I, times the frequency, F of I, divided by N, where N is equal to the sum of the frequencies. Okay, so that's what those symbols mean. So in this example, we know the mean is going to equal 0 times 11 plus 1 times 25 plus 2 times 10 plus 3 times 9 plus 4 times 5. And all of this sum is going to get divided by 60 because that's the total amount of numbers that we have. So if you take your calculator right now, go ahead and do the multiplication, add them up to see what you get. So the sum is 92, and 92 divided by 60 is going to be approximately 1.53. That means that on average, according to this survey of these 60 people, they have about 1.5 pets. And obviously, it doesn't make any sense to have 1.5 pet, right? How are you going to have half of a pet? But in comparing statistics, let's say this is the case for the year 2018, and then in the year 2022, which is post-pandemic, now let's say the average has jumped to 1.78. So there you can tell that there's been an increase in the number of people who are pet owners. Okay, so in some cases, like right now, that decimal, it really doesn't make any sense because the data is discrete, but at the same time, we can see patterns in the data because there was, in my particular example, an increase in the number of pet owners. The second way that data is going to be given to you is in groups. In the middle, we have grouped discrete data, and on the far right, we have grouped continuous data. So grouped discrete data, notice how we are writing these intervals. These intervals are read 51 to 100, 101 to 150, 151 to 200, okay? So in this case, let's say that I am interested in figuring out the average. I have no idea what the actual raw data is. I just know that there is one that has from 51 to 100 beans in that tin. I have 4 tins that have 101 to 150. So the best representative in this case, because I don't know exactly what the raw data is to use the midpoints. And so to find midpoint, you're simply going to add 51 plus 100 and divide it by 2. So to find midpoint, or what they call sometimes the mid-interval value, is exactly the same thing. You're going to have to add 51 plus 100 and then divide it by 2. What you're doing is really taking the average of those two numbers in that interval. When I add and divide, I get 75.5 as my mid-interval value. And that makes sense. Between 51 and 100, the mid-interval value is 75.5. If I take a look at 101 to 150, I can do the same thing where I'm going to take my calculator and take 101, add it to 150, and then take that sum, which is 251, and divide it by 2, and I get 125.5. So that's how I'm going to get my mid-interval values. Go ahead and pause the video so you can find the rest of the mid-interval values and go ahead and write it down. So by now, you should have found all of the mid-interval values. And believe it or not, you're going to start seeing a pattern between these. So you have 75.5, 125.5, 175.5, 225.5, 275.5. Okay, now that I have the mid intervals, I can go ahead and find the mean, the average. So now my formula is going to look a little bit different than last time. The formula for the mean now that I have groups is going to be x bar, which is the mean of x, is the sum of the midpoints or the mid interval values times the frequency divided by n. And again, n is the sum of the frequencies. So in this particular example, the mean is going to equal each midpoint, 75.5, times its frequency, 1, plus the next midpoint, 125.5, times 4, plus 175.5 times 32, plus 225.5 times 47, plus 275.5 times 16, all divided by the sum of the frequencies, which is 100. So go ahead and put that in your calculator. So then the average amount of beans in each tin, according to my data, is approximately 212 beans. So that's how you find the average when you have the data given to you in groups. So if you look over to the right-hand side where it says the grouped continuous data, notice the presentation of the data in the table. In the one about the beans that we just finished doing, we saw it written 51-100. That means from 51 to 100. But in the grouped continuous data, since the data is continuous, notice it is presented to us already in intervals. The problem says the number of minutes that flights from an airport are delayed on a particular day. So this means that on any particular day or on a particular day, there were 15 flights that were delayed 0 to 15 minutes. There's also going to be 24 flights that were delayed up to 30 minutes, 12 flights that were delayed from 30 to 45 minutes, 4 flights that were delayed from 45 to 60 minutes. And so our sample consists of 55 flights in total that were basically part of this survey or the investigation. When we are going to find the mean, the average amount of flights that on this particular day were delayed, when we're about to find the mean or the average amount of time in minutes that the flights were delayed on any given particular day, then we're going to use the same exact formula we used previously, which involves the midpoint. The reason is that we don't know the exact raw data, so we don't know exactly the amount of minutes. And also time, if you remember, is continuous data. So the fact that we can keep breaking it down, it means that each one of these flights was delayed possibly, 15 minutes and 45 seconds, for example, if you want to be really precise. So right now, our job is to figure out the midpoint for each one of these groups. The way you're going to find the midpoint, or what's called the mid-interval value, is to take the 0 plus the 15, which is 15, and then divide it by 2, and you're going to get 7.5. If you do the same thing for the next one, 15 plus 30, you get 45, and if you divide that by 2, you're going to get 22.5. So you're going to have to do the same exact thing, 30 plus 45, take the sum, which is 75, divided by 2 is 37.5. And then finally, you're going to do 45 plus 60, and you're going to divide that by 2, and you're going to get 52.5. So these are going to be your midpoints or mid-interval values. To figure out the average amount of time that these flights were delayed on a particular day, you're going to have to do the same thing. You're going to have to take each midpoint, multiply by the frequency, take the second midpoint, which in this case is 22.5, multiply by 24, which is the frequency, then plus 37.5 multiplied by 12 plus 52.5 multiplied by 4, and then all of that added together is going to be divided by the total amount of frequencies, which is 55. So go ahead and put this into your calculator. So our answer is going to be 23.55 23.9 approximately. So that means that on average, there's approximately 23.9-minute delay for a particular flight on a particular day. Other things for us to consider: mid-interval values and upper and lower boundaries. When data is grouped, the classes that are formed have upper and lower boundaries. The mid-interval value of a class is halfway between the upper and lower boundaries. That's the midpoint, the mid-interval value. Generally, the upper and lower boundaries of a class are taken from the class label, and the mid-interval value is calculated the way I showed you earlier, which is take the upper boundary plus the lower boundary and take the average, so divided by 2. The next part of this is important because we're going to be creating histograms. And they basically want you to realize that when data is given to you in intervals, like from 0 to 10, 11 to 21, there is a gap between the 10 and the 11. And because in a histogram, it is a bar graph where all the bars have to touch, then you want to make sure that gap does not exist. So what you need to do is find what's called a true class interval. And the way you do that is that you would take something like 0 to 10, and you're going to take half off the first number and add half to the last number. So in this case, it's going to be negative 0.5 is less than or equal to x less than 10.5. If I take the second interval from 11 to 21, I'm going to take half off the first number, which will make it 10.5, because 11 minus a half is 10.5, less than or equal to x, less than, and now I'm going to add half to the last number. What that does is not allow for us to have a gap anymore between those numbers, which means that when I go to draw my histogram, then my bars are going to connect, and that's exactly what we wanted to do. Now, in other examples that data is given to you, you're going to notice that there are no gaps. So in this particular case on your screen, if you look at what I boxed in blue, there is no gap because it goes from 0 to 10 and then 10 to 20. There's also no discrepancy. If the data contains a value of 10, it's going to be included in the first one because of the less than or equal to 10. If it includes a number like 20, obviously it's going to go in this second one. If it includes a number like 11, it's going to go in the second one because 11 is bigger than 10. So there's still no discrepancy because there's only one less than or equal to in that interval. In another video, I'm going to show you how to create a histogram. So for now, I want you to realize that if this is basically what you are graphing, notice when data is presented in these type of intervals where there's a jump from 100 to 101, 150 to 151, you will have to find a true class interval. That is when you use the idea of bounds and take off half from the first number and add half to the last number. But if data is given to you already with inequalities a lot of time and you don't have that gap, which is the case right here, then there's no need for me to do a true class interval. I can go ahead and create my histogram as is. Hope you found this video helpful.